All right. So variables in Java. This again, this is am I recording? Yeah. This is probably the trickiest part because you have to remember that you have to decide initially what a variable is going to be when you define it. Okay. So variables in Java, it's basically like this. Whatever the type of the variable is, the variable name is camel case by convention. So if we have something that we've defined, right? So if we have a recipe, right, or something like that, we want to make an instance of our recipe. We have to say recipe and then the name of our variable. Okay, so this little step in front of the variable is really, it looks deceptively simple, but it's kind of a big stumbling point. So just practice, 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 right? So Java makes a distinction, just like JavaScript makes the distinction. I can't remember if Python does. Does Python have primitives? I'm blanking.
It does.
Yeah. Most languages do. Most languages will make a distinction between a primitive and a composite or different terminology, right? So the primitive types in Java, and there are 8 of them. The platform only introduces, I think, 4, 5, or 6, but there are 8 total. These are all of the primitive types in Java. So we have a Boolean, and the size in our case matters, right? So in Java, the size of the primitive type will be relevant. Okay. Um, with Java, we're more in control of the actual like not we don't directly control the memory allocation, but it's more of an issue because Java is compiled and it's much faster, so it matters how big our variables are. So Boolean is 1 bit. Does anybody know? I know you have some. We have some CS people here. What is a bit? Nobody knows what a bit is. Anyone? Anyone?
Is it like the smallest storage or something?
Mm-hmm. It's either a 0 or a 1. Bit is short for binary digit.
Um,
When we put stuff in our computer, right? When I say name equals Tyler, we can't like crack open my computer and take my hard drive apart and find Tyler written anywhere, right? All a computer knows is ones and zeros. So when it stores the string Tyler, it takes each character, right? The T, for instance, and it has a corresponding number that's associated with T, right? So um, I don't know how far I want to go into this, but let's just go into it a little bit. So if I store the character T, the computer sees it as, depending on if it's capital or lowercase. So a lowercase t is 74, a capital T is 54. So when it's storing my name or the first letter of my name, it's storing 54. But it's not even storing 54, right? What is it storing?
A bunch of ones and zeros.
Yeah, the ones and zero representation of 54. And where's my calculator? So if I, do you guys see my calculator? There you go. There you do. So if I type in, let me make it a little smaller. So if I type in the decimal 50, I forgot what it is now, 54, doesn't matter. So if I type in 54, right? The computer, that's how the computer is storing the letter T. So what the computer is storing is this. That's T into a computer, right? So the zeros and the ones, all a computer knows is high voltage, low voltage, right? The little silicone chips have either a high or a low, on or off, yes or no. So it turns these 8 switches, and in the case of a character, it's more than that, but this represents the character T. Okay. So when we have our Boolean type as 1 bit, then it's either 0, it's either 0 or 1, right? It's either 1 or 0, right? That is super efficient, right? Doesn't take any space at all. Okay. And have I lost you? Let me see if I lost anybody. Who's lost? Let me take a poll. Whenever I go into binary, I get scared. How do I launch it again? Okay. Okay, okay. 3 people. Let me just share. Some people aren't even responding, so but so don't worry too much about this and the binary and all that stuff. We don't have to go too low level, but I just want you to understand that in terms of space in our computer, this is how much space is required to store whether something is true or false. It's either, if it's 1, it's true. If it's 0, it's false. Okay. A byte is 8 bits. That's just the term, right? So if we have 8 binary digits, 8 bits, that's a byte. Just a fun fact, 4 bits is a nibble. And that's computer science is full of those silly little things like that. Okay. But a byte is basically the smallest, I mean, not the smallest, but it's the most common division in how we store data. Okay. So a byte is 8 bits. A short is 16 bits. So that just means that it's twice as long. And again, these numbers will come into where's the rest of it? I guess that's all of them. Okay. So a character is 32 bits, which is pretty big, right? Okay, I don't want to go too far into this, but this is basically all of the primitive types that we have in Java. So Boolean, byte, short, int, long, float, double, char. You don't need to memorize them. If you ever have to look at this chart, which you'll have to look at it one time when we talk about type conversion, but don't, otherwise don't worry too much about the sizes. Oops. Okay, let's make some variables. By the way, I have this, if you see code as you're reading and doing your reading for the day, if you see code, my advice is run it, right? Copy and paste it into your editor and just get used to seeing the output, making sure everything works, making sure you understand everything, okay? All right, so, whoops. I want to make a byte variable. So I want to store something in a byte. So I'm going to say byte, my byte equals, and then whatever I want to store in a byte. I'm just going to store 100. Okay. What did I forget? I'd like to say I did it on purpose, but I actually forgot. I forgot a step. It's very important to Java.
The static void main thing.
Exactly. So we have to have our entry point. So in order to do that, if you installed the Java extension, you can say public. All you have to remember is PSVM tab, and it'll automatically insert it for you. Let me make this a little bigger so you guys can see. Okay. So let me move this inside that method. And if I want to see this, how would I print this variable to the screen?
System.out or print line. Byte.
Yeah, so
Byte.
system.out.println, right? But again, there's a shortcut, just S out. Why isn't it working? There we go. So system.out.println. What I'm going to do is show you a variation of this. So print line, or the print ln, all this means is it's going to print to the screen and it's going to insert a new line character. So when we print, it's going to basically push everything down to the next line. So we don't have to do this. We can just say print, and I'm going to do something called printf. And this is a carryover from the C and C++ programming languages. Printf just means print format. So if I want to print out this variable and actually have some reference and have some idea of what's printing, I can make a string. I can say my byte is, and then I can use a format specifier. And I have to add my new line because the only way to add a new, or the ln adds a new line, but if you use printf, it doesn't. So I'm going to insert my new line character. And then this %d is what's called a placeholder. So the %d will basically take whatever I put as a second argument to the printf, and it will stick it inside this string. Okay, so it's kind of like the prepared statements in Python where you wrote your SQL statements, and you remember you had the % and you put your variable in there and then s. So this will work the same way. So I can put my byte here, my byte. Okay, and now when I run this, it's running the wrong stuff. Hold on. Open this in a new terminal. Close this stuff. It's got to think for a minute. There we go. Cool. So now I get my byte is 100. So same thing if I want to make a short, my short equals 4. Well, we'll do 22. Okay. And I'm going to copy and paste these so you guys don't have to watch me do it. Can I? Okay, so I have if I want to make an integer, I say int, set my integer. If I want to say make a long, set my long. If I want to set a float, then that's not there. And double, and then the last, that's 1, 2, 3, 4, 5, 6. What am I missing? Char. My char is, let's just say T. Notice that I use the single quotes because it's a character, not a string, right? We make the distinction in Java between characters and strings. And then finally, a Boolean equals true. Okay. So if you declare a variable, we have to declare the type, right? What do we notice about my file?
Error.
Error. Good. Why? How do we know there's an error?
It's that floatus.
Yeah, we got a red underline and it's red, right? It's just like a big stop sign, right? So we know that if I try to run this, it's not going to work, right? So we got to fix this. Does anybody know what's wrong? Usually if you hover over, there we go. Yeah, so the little light bulb here will give you some indication. Sometimes it's helpful, sometimes it's not, but it gives me a couple quick fixes. It says add cast to float or change type to my float. Okay, so what's happening here is these are what's called literals, right? So if I type directly the numbers 42, or if I type the string Tyler is cool, that's a literal, right? It's an actual object in a programming language. Java by default, the literals are doubles. So basically what I'm doing is I'm trying to take a double and put it in a float. And Java doesn't like that. So there's two ways I can do it. I can coerce this into a float, which we'll talk about in a minute. We'll talk about coercion in a minute, but I can do this. And that'll fix it. Or in Java, we can just add an F at the end, and that will indicate that this is a float instead of a double. Okay. And that's probably the more conventional way to do it.
What is a float again?
So float, there's different data types, right? So if we go back to here, if I make a variable and I say it's a float, and if I put something else in there, Java's going to complain. So if I make a float, right, and I try to store a double in it, it's going to complain.
So
Most-
all decimals are doubles, or
So yeah, by default, the literals in Java are doubles, right? So when I just make 3.14 without the F, Java sees it as a double. So I gotta tell Java, hey, this is supposed to be a float.
can decimals be long or is it?
Can decimals be long? I don't think so. Long is, I think
Okay.
for floating point, it's either float or double.
Okay.
I think you can have decimals with a long data type.
Can you?
Yeah, because it's more space. Anything with more space is generally okay. Yeah, you should be able to store a decimal point in a long.
It doesn't like it.
Well, because you have the F, you might have to.
Oh man. Does that to coerce it? Yeah, that'll work. Okay. Cool. Yeah, you can. Sorry. Thanks, Christian. Okay. Any other questions about this? Let's put it back as a. Okay. So again, let me just copy this so you don't have to watch me do it. Oops. Okay, so and take that out. So if I want to print all these out, there's a format specifier for each of the so if I want to print out a number, it's basically %D. If I want to print out any type of floating point, it's got to be %F. If I want to print out a character, it's got to be %C. And then for Boolean, it's %B. And I have a list of all the format specifiers in the notes, I believe. Let's see. And it's over somewhere else. But anyway, if I run this, let me save the file, run it. So it gives you all of the variables that I created here and their names. Okay, so these are all, again, the primitive types. When we store primitive type in Java, it stores the value itself. Okay, so if I say byte, my byte equals 100, then 100 is stored here. Okay, now, if I want to perform any type of operation on the number, or if I want to store this number in a more complicated data structure, I can't store the primitive type, right? Most data structures will take it has to be an object. Okay, so if I want to get the object version of this, there's what's called wrapper classes. Okay, so basically every primitive type has a corresponding wrapper class. A couple of them are spelled differently just to confuse you. But if I wanted to make a object or a number that's an actual object, then I would make it into or use its wrapper class to define it. Okay. So if I do, I'm just going to do a couple of them so we don't take too much time. So if I want to make an integer, that's an actual object, then I would say integer, the wrapper class, define my variable, my int obj equals 42. Okay. So again, the difference between this int, and for some reason my mouse isn't highlighting. That's weird. The difference between this int and this int is this is primitive. This is an object. Okay, so this is like kind of when you think back to Python where we made like recipes and books and all that stuff. This is an actual object that has properties and methods. So if I now, any questions about that so far? Let me pause there because this is a little bit different.
I'm assuming you can do that with all the types. So like, could
Yeah.
you do capital float, capital character, things like that? Yeah, okay.
And I guess I have to have the, yeah, exactly. Yeah, so all of these have the corresponding wrapper class. And again, it's for integer, it's spelled, the word is spelled out, and for character, the word is spelled out. Otherwise, it's just a capitalized version of the primitive. Okay. Now, what this does, and that's really small, let me make it bigger for you. So now that I've made this an integer object, what do I call this? My int. So if I use my int and say dot, this is all I can do. I can cast it. I don't know what these other two are. Oh, var is create a new variable. Par, I don't know what that is. But there's basically, it's just ones and zeros. There's nothing to it. Okay. If I say, and that's what I said, ny for some reason, probably because the n and the m are right next to each other. If I say my int object dot, oops, now I have all of these methods that are available. Okay, so basically the wrapper classes just add functionality to a primitive, right? So if I want to get its max value, it's here somewhere. I can't remember how to find it. Where is it? There it is, max value. So if I want to find out the max value of an integer, I broke it. There it is. So that is the max value, the biggest value we can store in an integer. Okay. Same with all the others. If I can find the max value of any of the other types. And I'll just put this in here so you guys have it.
What would be the max type for a Boolean? Just one? Or would it be
Good
true?
question. So, but that doesn't make sense, right? There's no max value property for
Yeah.
Boolean. Yeah. But my if I do sout my float obj dot max value, oh, I misspelled object. Oh my gosh.
So
I'm a much better typist when there aren't 10 people watching me. So
is that max value mostly useful for checking this kind of information, or is this like applicable to when
it's
you have like
it's helpful for me to explain, like you would probably never use it, but it just helps me show you like these are some of the cool things you can do with the wrapper class. So there's other more useful excuse me, there's other more useful methods. Max value is just one of the properties that we have available. So if you are having issues with casting or something like that, you can use this if you need to. But there's let's see. If I look at my int obj dot, so there's others like get class, byte value, which will display more helpful information than, you know, the max and min value and stuff like that. Okay. All right. Any questions about data types?
Is there something that's different for like negative numbers or?
Yeah. So the maximum you can store in an integer, they give you this number. That's because it's signed, right? So they reserve one of the bits for whether it's positive or negative. I can't remember which way it goes. I think it's a 1 if it's negative. I could have that backwards. But yeah, there's fewer total numbers available because it's positive or negative. Yeah. Cool. Any other questions? So which is better? Which should we use, the primitive or the wrapper?
I'm assuming the wrapper, because primitive seems like it's old school. You know,
We want to be
just
with
the
the
name.
times, right? We want to be cool programmers. You would think the
Oh,
rule of
no.
thumb though is you want to minimize the memory you're using, right? If we're making an object, we're taking up a lot more space, right? All of these methods we have available, right, take up space, right? So the wrapper class is like, I don't know, I don't remember the sizes, but they're a lot bigger than the primitive versions. So if you can, if at all possible, you want to use the primitive types just because they're smaller, right? We have the sizes here, right? The wrapper class for an integer primitive is 32 bits. I think the wrapper is like twice that, or if not 3 times that. Okay, so there are instances where we have to use the wrapper class. We'll get to that when we get to it, but if possible, you want to use the primitives just because they're more memory efficient. Okay. Yeah, Christian, I think that's right. It's like 3 times the size. I think some of them are even bigger than that. All right. Any other questions about data types? So the question may be, how do you know the difference between primitive and, what does the platform call it? Can't remember what they call it. Primitive object types. So an object type is like the capital I integer. So the difference basically is if it's not one of these 8 primitives, then it's an object type. Okay, so those 8 primitives are the only primitive types. Everything else is going to be an object type. All right. Okay, so let's go to, let me stop.